Actually, in metabolic acidosis, the compensation, that is expected PaCO2 is expected PaCO2 is 1.5 into bicarbonate plus 8 plus or minus 2. This is the formula for calculating the expected bicarbonate. While in metabolic alkalosis, it is 15 plus bicarbonate. In crude way, we can use this formula for metabolic acidosis also. So, for some example, metabolic acidosis, pH 7.3, bicarbonate 20, the expected PCO2 will be, the expected PCO2 is bicarbonate plus 15. So that is 20 plus 15, that is 35. For metabolic alkalosis,
pH is increasing, bicarbonate is 30, the expected PaCO2 is 30 plus 15 is 45.
pH 7.49, bicarbonate 30, the expected PaCO2 is 45, that is 30 plus 15. So from step 3, that is the primary disorder is respiratory, you have to calculate the compensatory. It's different for respiratory acidosis and it's different for respiratory alkalosis also. Okay. So for respiratory acidosis, as we telling here, for every 1 millimeter of Hg, so every 1 millimeter of Hg increase in PCO2 from 40 So for respiratory acidosis, for every 1 millimeter of Hg increase in PaCO2 from 40, there should be increase of bicarbonate by 0.1 milliequivalents from the normal value. Similarly, for chronic disorders like COPD is like that, for every 1 millimeter of increase in PaCO2 from 40, the bicarbonate will increase by 0.4 milliequivalents from normal value. So for 1 milliequivalents it is 0.1. For 10 millimeter of Hg, what will happen? It should increase by 1 milliequivalents. Similarly here for 10 millimeter of Hg, this increases by 40 equivalents. Milliequivalents. So let's solve this problem. The pH is 7.6, PaCO2 70, expected bicarbonate. So it is a respiratory acidosis. So for chronic, for acute, that is every 10 millimeter of Hg rise, 1 milliequivalent should be increased. So here it is from 40 it is 50, 60, 70, that is 30 millimeter of Hg rise. So into 3, that is 3 into 1 milliequivalents, that is 3 milliequivalents should be raised of bicarbonate. Similarly for bicarbonate for chronic, for every 10.4, sorry, every 10, 40, so for every 30, that is 40 into 3, that is 120 milliequivalents. Sorry, this is not 40, it's 4 milliequivalents. So for every 4 into 3, that is 12 milliequivalents should be increased. 12 milliequivalents. Okay, so from normal it is 24 plus 3, that is 27, and for this 24 plus 12, that is 36 milliequivalents. So next comes the respiratory alkalosis, that is hyperventilation. In acute case, for every 1 millimeter of Hg decrease of PaCO2 from 40, the bicarbonate should decrease by 2.2 milliequivalents from normal value. So similarly for 10 millimeter of Hg, it is 2 milliequivalents. Then for chronic, for every 10 millimeter of Hg decrease, it is 4 milliequivalents. This is the difference. So we'll see an example with pH 7.5, PaCO2 20. So it is a respiratory alkalosis because PaCO2 has been decreased. You see the acute form for every 1 millimeter Hg 0.2. So here comparing to 40, there is 20 millimeter of Hg decrease. 20 millimeter of Hg decrease. So 2 into 2, that is 4 milliequivalents. Because for 10 it is 2, for 20 it is 4. So from 4 milliequivalents decrease, that is it should be 20 milliequivalents expected bicarbonate. Similarly for chronic, it is 2 into 4, that is 8. That is it should be 16 milliequivalents expected bicarbonate. Next is the given value and expected value. If the given value is expected value, the disorder is single disorder. But if the given value is not equal to expected value, the diagnosis is mixed disorder. The primary diagnosis is metabolic. Metabolic means bicarbonate. If the given PaCO2 is more than the expected, for metabolic, if the given PaCO2 is more, which means more carbon dioxide retention, there will be additional respiratory acidosis since the carbon dioxide retention is more. So there will be additional respiratory acidosis. Okay, acidosis. Similarly, if the given PaCO2 is less than the expected PaCO2, which means no such retention, for metabolic, we are compensate respiratory components are working, but no such compensation occurs. It is less. So as not expected, that is, the expected PaCO2 is this much, but it is less than that, we mean that it is alkalosis, which means it's a respiratory alkalosis additional. Next come, if the primary diagnosis is respiratory, next you check respiratory means it's we're dealing with carbon dioxide. So you check the given bicarbonate. When checking the given bicarbonate is more than the expected one, which means more alkalotic component is occurring there, which means metabolic alkalosis is additionally seen there. So metabolic alkalosis. Metabolic alkalosis is additionally seen there. But if you tell you, if the given bicarbonate is less, so compensation is not proper, which means more towards acidic form, that is, it's metabolic acidosis additional form. Okay. Next is acute and chronic disorders. If the pH is in extremes, is likely an acute disorder, as kidney works slowly to compensate, because we know that it's then comes the respiratory buffer, then comes the kidney. So if the pH is near normal, which means it is compensation has occurred, is likely chronic disorder as the kidney has compensated. That is change in pH is near 2.1, that is 7.44, 7.45, like that, 4.6. It's near to name compensations. So this is the chart. So respiratory disorders, for every 10 change of PaCO2 from 40, the pH changed by 0.08 from 7.4. For chronic, it is 0.03. So now we'll see some example to familiarize the disorders of acid-base system. First, we see a case where the pH is 7.30, the bicarbonate is 20, the PaCO2 35. Okay, you check here. The pH has been reduced, the bicarbonate is low, the PCO2 is near normal. You check the ROMS, ROMS, respiratory opposite, metabolic same. So it's a metabolic occurred here. Okay. So what we do is that we conclude it as a metabolic acidosis. But the PaCO2 is normal. You check. Metabolic acidosis. Metabolic acidosis. Next, we check the compensation. In metabolic acidosis, we check 1.5 into bicarbonate plus 8 plus or minus 2. So 1.5 into 20 plus 8 plus or minus 2, which comes to be 30 plus 8 plus or minus 2. So it comes to be 38 plus or minus 2. That is 36 to 40. That is the expected bicarbonate level. Sorry, it's expected PCO2, PaCO2, because it's acidosis. So we can tell that the PaCO2 is near normal, which means it's compensated. So it's a single disorder. It's a single disorder with compensation. It's compensated. So in crude way also we can tell that the expected PaCO2 is 15 plus bicarbonate. That is 20 plus 15, that is 35. It's clearly similar to the PCO2. So it's compensated. Okay, compensated metabolic acidosis. Next, we see the pH is 7.28. The bicarbonate is 20. The PaCO2 15. You see here, the pH has been decreased. The bicarbonate has been decreased. The PaCO2 has been decreased. So it is metabolic. So it is a metabolic disorder. The first impression, we compare it as a metabolic disorder, and we check whether it is acidosis. Yeah, pH is less, so it's probably most acidosis. We check the compensation. You can crudely write it as 15 plus bicarbonate. That is the expected compensation. So here comes 15 plus 20, that is 35. Is it compensated? The bicarbonate, the expected PaCO2 is more than the expected, the expected PaCO2 is more than the given PaCO2. So which means there is a return. So there is less retention of carbon dioxide. There is wash out because the carbon dioxide has been washed out. That's why it's showing this only 15. So there is an additional metabolic, additional respiratory alkalosis. It has not been properly compensated. It's a 2 disorder because expected is not equal to given. Okay. Next, third question comes as pH is 7.50. The bicarbonate, it is 30, and PaCO2 is 60. This is the given values. We check. The pH has increased. The bicarbonate has increased. The PaCO2 has also increased. So metabolic. So you tell it as a metabolic alkalosis since the pH has increased. Does it compensated? You see, metabolic alkalosis. We check the expected PaCO2, which is expected. Bicarbonate plus 15. Is it? So 30 plus 15. It could be 45. But here it's 60, which is more, which means for metabolic alkalosis, the compensation is respiratory acidosis. Respiratory acidosis means more of the CO2. That is, the CO2 should be retained in the body. Yeah, it is returned, but the retained CO2 is more. That is more than the given expected. So it's not properly compensated. We could say that there is additional respiratory acidosis because more than we expected. We expected only 45, but the given value is 60. So two components, it is metabolic alkalosis and respiratory acidosis. So thank you for listening. Have a nice day.